All right, welcome everyone. Today is Wednesday, January the 24th, 2024, and this is the Cluster API Karpenter feature group meeting. We're a sub-project of Kubernetes SIGs, and we follow their guidance. So it's just Jeremy and I today so far. So Jeremy, you said you might have a topic to get into. What should we get into?
Yeah, so we've been looking at how we're going to run Karpenter on our clusters. And given that it's recommended that you don't run Karpenter on the nodes that it manages for itself, we were going to, in our EKS clusters, basically have an ASG that either is a static pool of two nodes or is an ASG that's managed by an instance of cluster autoscaler that just manages those nodes. There's some problems with that, one being that we don't really want to manage nodes in two different ways with two different technologies. Another being that while with Karpenter, you gain the ability to very dynamically define and easily define what node types you're running. We lose that flexibility with the static ASG, and we have to update those in a different way. So if we need to resize them for Karpenter, because we would like to have them optimally sized so we waste as little space as possible, if we have to resize those, it's a bigger effort. So we started brainstorming just yesterday with the idea of managing that smaller group of nodes for Karpenter with a Karpenter instance running on the nodes that those Karpenter nodes would manage. So we basically have Karpenter nodes managed by Karpenter living, and the other Karpenter instance living on nodes managed by the other Karpenter instance, almost like a chicken and egg scenario there. And we worked out a migration path for it. And the more we thought about it, the more sense it made. And I'm kind of wondering if that really is a good idea or just some crazy thing that sounds like it would work, but there are some gotchas that we would need to consider in that.
I feel like Jonathan showed up at like the perfectly best time for this because I don't know if it's a good idea or not. It sounds like an interesting topology. But like, could you describe that again? So you have like Karpenter nodes managing other Karpenter nodes. Can you talk about that topology a little more?
Yeah, so if we think about it as like a Karpenter admin node pool, right? Which would be, like probably just about two nodes that Karpenter would be running on. And that would be the Karpenter like cluster scaling instance. So those two nodes, the Karpenter that's running on those two nodes would be managing the scaling for the nodes for the rest of the cluster in a different node pool. And then living in that node pool would be a Karpenter deployment, which would manage the Karpenter admin node pool. So we have two node pools and a Karpenter running on each node pool, managing the other node pool.
I mean, it certainly sounds complicated enough to make any SRE weep. But
we see it as being a little more simple than, or giving us more flexibility and being a little better than running cluster autoscaler in the main node pool to manage the node, the node group that Karpenter is running on.
I mean, certainly it keeps all your configurations and everything the same then, right? So you don't, like you said, you don't have to have this kind of like dual knowledge going on within the cluster and everything. I mean, it makes a lot of sense from that perspective to me.
Yeah, and if we need to resize the Karpenter nodes to get them to a more optimal instance type, we can, just change that configuration and have it update instead of going through the effort of updating that ASG and then rolling those nodes over, which is a more hands-on process. Right.
So when you talk about using cluster autoscaler, you're using it with the AWS provider then, right?
Yes.
Okay.
Yes.
Because that's one of the things, you also brought up cluster API and all this, and yeah, like you would using the AWS provider of the autoscaler, you definitely lose, like you said, you lose that ability to specify the instances in a more direct manner because of the way the ASGs operate. But if you were using the cluster API provider, then you could absolutely specify the instance types that the cluster autoscaler would use. But then you would lose access to like the ASG features, right? So it's kind of like, how do you want to split things? Um, Jonathan, did you have any thoughts about this, or does it sound like something you would say, "Hey, don't do that"? Or
Yeah, sorry, I'm still trying to contextualize the conversation because I just jumped in and I'm driving right now too. But can you give me, sorry, a little bit more context into what exactly you're proposing?
So instead of, so the, coming back to the cluster API part is, yes, we're going to go to cluster API, but that's not going to happen until after we roll over to Karpenter by, a few months to 6 months.
Gotcha.
So in that sense, we need to have a way to manage the nodes that Karpenter is going to run on, the Karpenter instance that's going to manage the scaling of the entire cluster.
Mm-hmm.
And so originally we were going to have an ASG and have cluster autoscaler manage that ASG. And then we thought maybe this would be a lot more simple if we ran another instance of Karpenter on the cluster and had that manage the nodes that the primary instance of Karpenter is running on.
Got it. And so what's managing, this is for, okay, I'm trying to think of the topology here. So Karpenter is managing the nodes for the, the instances for Cappy to run against the other clusters on?
Cappy isn't in this picture yet.
Oh, I see. Okay.
I think what we're talking about here is you have like cluster A that is being managed by Karpenter. And that Karpenter instance that is managing cluster A is running in cluster B. And cluster B also needs to be managed by something to handle when growth happens. So instead of using autoscaler for that, using Karpenter to manage that. But it also sounded like, Jeremy, you were saying you had kind of like an Ouroboros situation where it was like one cluster was managing the other, and then once you deployed that one, you had it manage the first one.
This wouldn't be two different clusters. This would be two different node pools in one.
Oh, gotcha. Okay.
In one cluster. So we would have Karpenter in one node pool managing another node pool, and in that node pool is a Karpenter instance that's managing the first node pool.
Is it kind of like a ring-based approach where you just have like redundancy built into like a ring, or is there like a like a main, like a primary secondary thing?
This would be more ring-like. It would be,
got it.
The secondary Karpenter would just be managing a node pool that basically has two nodes in it.
But do you have like A manages B, manages C, C manages A, or do you have like A manages B, C, D, E? You get what I'm saying?
No, I don't think I follow that.
So like Karpenter A manages cluster B's capacity, Karpenter and then you have an instance of Karpenter B running on, like, it's like the Ouroboros situation that Elmika is talking about, where you've got like the capacity of your secondary is managing, or the Karpenter on your secondary is managing your capacity and your primary, so you have some redundancy. Because like, how do you manage the capacity of the primary Karpenter instance that's going to be managing the other capacity across other clusters?
So this is all just based in one cluster.
Mm-hmm.
So we would have node group A with two nodes in it that's managed by Karpenter B that's running in node group B. And then node group B has it's managing all the nodes for the cluster up to 498, because we cap our clusters at 500.
Mm-hmm.
And node group B, with all those nodes, is managed by Karpenter A that's running in node group A.
Got it.
But
Yeah, I think it makes sense.
did you say the carpenter that's managing node group A is running in node group B?
Yes,
Okay.
or Carpenter B is running in node group B, and that's managing node group A. Carpenter A is running in node group A, and that's managing node group B. The obvious, the biggest thing or the biggest issue I've come up with here is if we scaled them both to 0, we have no way to start it up. So we'd have to, pop up a bootstrap node that can kick the process off. Or, if we had Cappy, we could pop up a node or just manage that. And eventually this working group will solve this problem for us.
Right. Yeah. I mean, it sounds like it'd be fine to do. You just got to make sure that you have some sort of like minimum node pool size on each one of those to make sure that it never, you have to make sure that it never gets rid of the capacity to run the carpenter, right?
Yeah.
What happens if the capacity that Carpenter's running on, like not just like it scales to 0, but like the capacity it's running on just goes bad for some reason? Like there's an outage or whatever.
Mm-hmm. Yeah, we've thought of that, and I think I'd need to like war game that scenario out to work through it. This is just kind of a thing we thought about yesterday because we were running into this issue of, okay, we need to add the ASGs for Carpenter to run on all over the place. What size instance should we create for that? And we came up with, well, we don't exactly know, so we would need to provide something that's going to be big enough for growth and adjustment, but we haven't run Carpenter yet on some of these like larger nodes, so we're not exactly sure what resources it's going to require. Doing it this way, we can dynamically adjust that after the fact instead of going through the rigor of dealing with an ASG modification, since we're not on Cappy yet.
I mean, I think that makes sense to me, like what you're saying there. Yeah, like in terms of the topology you're proposing, like aside from the scaling to 0 or like kind of the disruption and notion, like I don't see why you couldn't run it that way. Like it doesn't sound like inherently dangerous to me, but you got to make sure those limits are in place so that you would never run out of,
Mm-hmm.
you would never run too low on resources, right?
Yeah.
Yeah, it's an interesting problem. Part of my question too is like, do you see like, so in node group, are there workloads happening in each of these node groups as well? Because it sounded like one of them was just running like administrative stuff, like it was just running the carpenters and whatnot.
Yep, that's correct. Node group A would just be Carpenter. We might, I could see shifting some other administrative workloads in there, if it made sense. And I'm struggling, coming up with a good reason to,
Right.
to do that. We don't need to isolate it like that. And so node group A just running Carpenter, I would expect that would be fairly static.
Right.
Not a lot of churn there. We just need to be able to, resize those nodes if Carpenter, needs more resources, like, say, I don't know, say we hooked it up to a VPA and it starts to grow and
Right.
it doesn't fit on anything
Right.
anymore. It can just dynamically scale that up. Node group B would be everything else, all non-Carpenter admin pods, tenant pods, whatever random apps our tenants are running.
Like node
And
pool
that one
B
is going
makes
to be
sense to me.
scaling up and down.
Yeah, node pool B makes a lot of sense to me. Like that, like why you'd want to have Carpenter managing that. Node pool A was the one that I was like more thinking about in terms of like, okay, this, like, does it really need to be managed by Carpenter? But I get what you're saying. Like really what you want is you want to be able to do like just vertical scaling in that. And that's really all that matters. You're not really that concerned about horizontal scaling there.
Yep.
Yeah, that makes a lot of sense. But yeah, that's kind of a difficult way to look at it, because I think my gut reaction is like, yeah, like cluster autoscaler plus VPA work pretty well together, you know? And so like, there's probably, well, I don't know. I don't know that it would work as well as the way that Karpenter can kind of reevaluate the usage. I don't know. Like this might even be one of those situations where having another way to look at this, right? Like, you know, like something like Kata, right? Where you could imagine if you were using, like, once you make the transition to cluster API, right? Now you've got node group A is basically in some sort of machine deployment of cluster API. And at that point, using a VPA and putting the external metrics out to Kata, so allowing Kata to read what the VPA is doing, and then Kata can just kind of like make adjustments to what you're doing. You know, like it could make adjustments to the machine deployment or something at that point. But I think like the difficult part here is that you're going to be wanting to replace a machine with a larger machine and then migrate the Karpenter workload to the new machine, right? So at some point, you're going to have to like, you're going to have to stop you're going to have to stop the Karpenter and then restart it on the new instance or whatever. I don't know. Have you tried that handoff at all? Does it work pretty cleanly for you?
We haven't tried it yet.
Okay, because that's where I'd get nervous. Like anytime I think about starting and stopping the autoscaler or the, you know, things like that, I always kind of like hold my breath a little bit.
Yeah. Yeah. It's when I, you know, when this idea was first proposed, it seemed a little crazy. But we started to dig into it, and it seemed to, you know, it seemed a little more a bit of a better solution than our other, you know, cluster autoscaler based one. And this, you know, as we said, this kind of goes away once we move over to Cappy, and once Cappy and Karpenter kind of, you know, get together in the end there.
Because I think like Karpenter is going to be able to do the reevaluation on these things on like a regular basis, whereas I have a feeling what would happen in the case of like cluster autoscaler, if this were to work on cluster autoscaler, it would have to be the situation where you have Karpenter running, and then that Karpenter starts to emit usage metrics that makes the VPA think it needs to have a larger size pod, right? That larger pod won't fit anywhere. In order to kick the cluster autoscaler into action, that larger pod would have to be like in a pending state, right? You'd have to be like in the middle of transitioning. So Karpenter is still running, and now like a pending pod is coming in with the larger Karpenter, you know, pod, and that pending pod would cause cluster autoscaler to push out, right? And that's not going to be ideal, I don't think. Whereas, you know, with Karpenter, it'll be able to, you know, through the consolidation, I would imagine it would be able to continually look at this and then see. I don't know if there's a way for it to measure when the metrics in that one pod change though, and then push to like, because if I understand the Karpenter mechanics properly, I would like the new pod that's coming in would have to become like unschedulable or something. And I just don't know how the VPA works with respect to like keeping the old pod around and then starting a new pod. Like, how does it handle that translation? You know, that's something I would be really concerned to look at.
Yeah.
How does this jive with in-place scaling? Like if VPA, I think there is talk of the in-place vertical pod autoscaler, right? Does it just go away then?
Yeah. But I mean, it's like, it is scaling the pod, but I think like really probably what this has the most crossover with is like the dynamic resource allocation stuff that's starting to come into Kubernetes. Because if you were able to use and I don't know how this would work on the back end, but like there is the notion of in the future having kubelets that could have dynamic, resources so that they could update their resources on some sort of way. And it almost sounds like that's the kind of thing that like is required here. But again, I think it gets into the mechanism of how does the handoff happen between the old carpenter and the new carpenter that needs more size? Like when it starts to push that, what does that look like? Because dynamically, vertically scaling a pod, you can do that, but you already have to have a bigger instance, right? So that means you would have already had a bigger instance running there. There'd be no reason to make a bigger instance. Good question though, Jeremy. This is like I can tell this is a good problem to solve.
Fun problem to test. Go break some stuff.
Yeah, totally. We're almost at the bottom of the hour here. So did you have any other kind of closing thoughts you wanted to add in, or is this helpful, I guess, at some level?
It was helpful. I think there's some things there to consider that I hadn't thought about previously. And the fact that no one said, no, that's absolutely crazy, don't do it. I think it's an indication that this is something worth pursuing and testing in this rollout process, because it's got the ability to dramatically simplify our rollover to Karpenter on clusters in place. Basically, we can deploy the Karpenter that would create the node pool for Karpenter in the cluster that exists, pop that node pool up, install Karpenter on that node pool to manage the rest of the cluster, mark all of the cluster autoscaler managed nodes as parked. We have this, park node idea, so we can gracefully terminate workloads and move them over. And once those nodes are parked, a process will start to drain them and move it over to Karpenter managed nodes. And then cluster autoscaler can be, flagged so it doesn't scale up, but can scale down, and then we can just have it clean up after itself and go away. And that drain process would also move the management or the original Karpenter instance that created node pool A. It can just move over to the new Karpenter stuff, and everything's happy and cleaned up. And so, in the ideal, world, in the scenario, it's like, oh, that's a very simple transition process. That's all automated. The cluster takes care of itself. Obviously, we're going to have a lot of testing there to make sure that nothing unexpected happens and blows it. It blows up in our face. Oh, everything just scaled to 0, and now we have downtime, right? So, yeah, and so yes, this has been helpful, and I apologize for being slightly off topic here, but
that's okay. I mean, like it was just the two of us, so like I'm happy to talk about this stuff, and but now you're on the hook though, right? Because we've had this good conversation, and I think the problem is interesting, but I'm going to want to hear more about this later once you've kind of done some testing or exploration, because I'm curious to know like how does it work? Like what do y'all see when you get into this? So, like as long as you're cool with that,
mm-hmm. Yeah, I can bring back results on that. I also see it as being a useful exercise for looking at, so how do we transition, how do we migrate our existing in place clusters to other things like
right.
CAPI, and when that shows up, because it is very, very interesting to consider. I got this cluster running now I'm going to pull the rug out from under it and rebuild its foundation, and no one is going to notice like a single thing. So
right. Yeah, I mean, that's like you said, like they always say, like it's like and the glassware is still standing or whatever, right?
Exactly. We don't
tablecloth out.
and we don't even want people to notice, right, that there was like a slight shift in the glassware as it moved over, or a little bit of water like splashed out. It's like we got to avoid all of that. We want absolutely nothing interesting to happen.
Right, totally. Well, that'll be the trick. Like I'll be curious to hear how it goes.
Yeah. Okay. Good. It's
right,
not
well-
it's not an absolutely crazy idea, so we'll go with that.
Yeah, we'll see how it goes. I guess, yeah, thanks for coming out, and I guess hopefully we'll see you in a couple weeks, and maybe yeah, we'll get on to the other agenda topics.
Cool. All right.
Thanks, Jeremy.
Thanks for your time.
Yep. Bye.
Bye.